This video, I'm going to go over the Math 3 Topic 4 Quiz 2 review. So I'm going to do all of the evens for this one. So for the first problem, we are asked to write the equation of the graph function. So this is going to be our 2 points on the quiz. When we're doing this, we're looking at the shape of the function to identify whether it's a cube root or a square root first. So remember, if it looks like this, that's when it's going to be a square root. So when I have a starting point and just one arrow, when it has an arrow on each side, that's when it's going to be a cube root. And so that means that this graph is that of a cube root function. When we're looking at a cube root to identify the equation of the graph, we want to look at the middle 3 points. So remember that we graphed a 5-point pattern for a cube root function. The first and the last point might be off the graph. And so what we're looking for is that middle point where it's kind of changing the direction from being like sloping upwards to sloping downwards. And so that point is the point on this graph 3, 0. So the point 3, 0, if I was graphing, that would be my middle point. And then I want to find the next point on either side. So the point to the left of that is 2, -1. And the point to the right of that is 4, +1. And so remember that within the graph of a cube root function, the middle point gives us h and k. So that means that for this graph, h is 3 and k is 0. And then a is the value that the y values are increasing by. So if I go from -1 to 0, I'm adding 1. If I go from 0 to 1, I'm adding 1. So all of my y values are increasing by 1. So that means that a is 1 for this equation. So if I'm using the transformational form of a radical, I'm graphing, or I'm writing the equation y equals a times the nth root of x minus h plus k. And so we've already determined that this is a cube root. Since our a is 1, our equation is just going to be y equals the cube root. H is 3, so x minus 3 is going inside the radical. Since k is 0, we aren't going to add anything at the end. So the equation for this is just y equals the cube root of x minus 3. Questions 3 and 4 are asking us about transformations of the parent function. So in this one, we're still trying to look at that transformational form of the equation of a cube root or square root or whatever root. In this case, we're looking at square roots, but we're still identifying a, h, and k in this problem using the structure. So looking at what we're given, the square root of 9x plus 27, a is supposed to be outside, and there's only supposed to be an x. So the coefficient on x should be 1, which means that our steps for this problem are that we want to factor out the value attached to x in order to identify these transformations. So since there is a 9 being multiplied times x, we want to factor that 9 out to determine what a is and what h is. Structurally, from our equation, we can already see that k is -3, but our a and our h are kind of hidden in this under the radical. And so if I factor out the 9 from 9x plus 27, I'm dividing 9x by 9, which gives me x. So it's always going to be that number because I have to have x minus h on the inside. And then 27 divided by 9 is 3. So under the radical, we now have 9 times x plus 3 instead of 9x plus 27. The whole point in doing this is I want to split that 9 apart from the x plus 3 so that I can look at this in transformational form because that value is related to my a and I need it outside of the radical. So if I split up the square root of 9 times the square root of x plus 3, the square root of 9 is 3. And so this is 3 times the square root of x plus 3 minus 3. So a is 3 now based on this. H is the opposite of what's being added to x. So it's x plus 3, so that means h is -3. So remember that each of these tell us something different. So a tells us that this is a vertical stretch because it's a whole number. If that was like 1/3, it would be a compression. So it's a vertical stretch by 3. And then H and K together tell us that this is a translation to the, sorry, not to the right, to the left 3, because 3 is, H is negative, and down 3 because K is negative. So this is a graph of a square root that has been given a vertical stretch by 3, a translation left 3, and down 3. Problems 5 and 6 are also worth 4 points. In this problem, we are identifying the domain and range of the graph. So notice that they've given it to us visually and using the equation. And so we'll see that our H and K are related to our domain and range. Since H is a horizontal shift, domain is a horizontal measure, our domain is going to have to do with our H value of 3, and our range is going to have to do with our K value of 4, because Y is vertical, K is vertical. So what I'm looking at here is that my graph starts at the point 3, 4. And so that point is actually going to be a piece of the domain and the range. So because it's a square root, remember that this graph only covers these x values, because I cannot take the square root of a negative and get a real answer. So as soon as I plug in a number like 2 minus 3 would be -1. So if I were to plug in 2, I would have an I plus 4, which isn't on the real axis. And so that means that my domain starts at that value of 3 and goes on forever. So the domain goes from 3 to infinity. You can also write that as x is greater than or equal to 3. So notice that that's the value for H in our equation. Similarly, our range, the whole graph starts here and it will continue increasing. And so the range of values starts at +4 on the y-axis and then goes on forever upwards. So it's increasing at a slower rate than the domain increases, but it's still increasing forever. So this would also be a range of y is greater than or equal to 4. Okay, so the lowest x to the highest x, so the leftmost to the rightmost, it goes from 3 and then infinity, and then our range goes from 4 up to infinity. For question 8, we're solving the radical equation. In all radicals, we do want to check for extraneous solutions. And so our first step is to get the radical piece by itself. So see how in 7, it's already isolated, so we would go into undoing the radical. Because this isn't isolated yet, we have to subtract the 5 before we can get started. So I have the square root of x minus 8 equals 7 minus 5 is 2. And so then when I square both sides now, to undo that square root, I have x minus 8 equals 4. So to get x by itself, we want to add 8. And so in doing that, we get an x value of 12. Remember that we want to always check for extraneous solutions. And so that means that we're plugging 12 into our original equation. So I'm taking 12 and double checking to make sure that if I take the square root of 12 minus 8 plus 5, that I get 7. So 12 minus 8 is 4, so that means the square root of 4 plus 5 should be 7. And so 2 plus 5 is equal to 7. So since that's a true statement, that means that our answer is good, that 12 is the answer to this equation. 9 and 10 already have the radical isolated. What makes these a little bit more complicated is that we have an x on both sides. So this is where we have to pay attention to our extraneous solutions more closely. So our first step for this, because the radical is by itself, is to square both sides. Again, we're squaring because that's a square root, so the little imaginary index there is 2. So we're squaring the square root of x minus 1 equals x minus 7. What we do on the left-hand side is easy. It just cancels out our radical. So this is x minus 1. Remember, on the right-hand side, though, it's more complicated. When I'm squaring a binomial, I'm multiplying it times itself. So that means that I'm taking x minus 7 and multiplying it times x minus 7. So I'm going to do that using a box right now just to organize my work a little bit nicer. And so x times x is going to give me x squared. Negative 7 times x is negative 7x. Negative 7 times x is also negative 7x. And then negative 7 times negative 7 is positive 49. I don't know why I just wrote a 45. It's positive 49. So looking at that, that means that I have x minus 1 equal to x squared if I combine my like terms, minus 14x plus 49. And so when I do this, because I have a quadratic, I want to get everything equal to 0 so that I can factor. Meaning I'm going to subtract x from both sides and I'm going to add 1 so that I can factor this expression. I wrote really large here. We're going to run out of space. So we have x squared minus 15x plus 50. And so what we're looking at here is what two numbers multiply to 50 and add to negative 15. And so in doing that product sum, our two values are going to be negative 10 times negative 5 is going to multiply to positive 50. And then negative 10 minus 5 is going to add to negative 15. So 0 equals x minus 10 times x minus 5. This means that our two potential solutions are x equals 10 and x equals 5. So we need to check to make sure that these work in the original problem. So when I'm checking for extraneous solutions, I'm plugging the 10 and the 5 into the original equation. So I'm just going to write this out and leave space for each of them since I have to do this twice. So when I plug in 10, 10 minus 1 is 9. So the square root of 9 is equal to 10 minus 7 is 3. So that says 3 is equal to 3, which is true. So I know 10 is good. When I plug in 5, 5 minus 1 is 4. So the square root of 4 is equal to 5 minus 7 is negative 2. Remember that when we're plugging these in, we're looking at principal square roots. And so it's always just the positive value. And so positive 2 is not equal to negative 2. So that means that 5 is an extraneous solution. So our only answer for this problem is 10. The final problems are solving radical equations where it's not a perfect square root. And so that means that we want to use whatever power is there in our index. So for this first one, we have the fourth root of 2x plus 2 equals 3. So that means that I want to raise everything to the fourth power in order to get rid of the radical because I'm matching it to the index of 4. So I have the fourth root of 2x plus 2 equals 3. I'm raising both sides to the fourth power. When I do that on the left side, it eliminates my radical and the index. So all that's left is 2x plus 2, the radicand inside, and that's equal to 3 to the fourth power. 3 to the fourth power is 81. So we have 2x plus 2 equals 81, which means we're going to have to subtract 2 from both sides. And then that gives us 2x equals 79. And if we divide both sides by 2, we're just going to write that answer as x equals 79 over 2. So to check this, what we're doing is we're plugging 79 over 2 into the original problem, which was the 4th root of 2 times x plus 2 should be equal to 3. And so when I do this 79 over 2 times 2, the 2's just cancel. So I have really the 4th root of 79 plus 2, which is 81. So is the 4th root of 81 equal to positive 3? Yes, positive 3 is equal to positive 3. So that means that 79 over 2 is the correct answer. Just in case you lost them, here are the answers to all of the problems. So remember that the odds that I skipped follow the same process, and those are the solutions.